Hi everybody, welcome back to the Feynman technique. Today we are going to be finding a general solution to this integral right here. Normally I would start with something like maybe 2 or 3 or something like that in place in place of the t there, and then I would create this function to solve the original integral. But today I figured I'd do something different and um, just solve this function of t directly. And we are going to be considering only values of t greater than or equal to 0. So I'll say that right now. T greater than or equal to 0. All right, so since we already have a function of t, why don't we use the Leibniz rule for differentiation under the integral sign and take its derivative? So derivative with respect to t is equal to the derivative with respect to t of this. And we can bring that, using the Leibniz rule for differentiation under the integral sign, we can bring that derivative right inside. So that's what we did. We took this derivative and literally just copied and pasted it right inside the integral sign right there. Okay, now this is a partial with respect to t. So this denominator right here is constant. So all we need to do is take the derivative with respect to t of this. All right, so what's that going to give us? Well, it's going to give us 1 over the argument inside the arctangent squared plus 1. Then times the derivative with respect to t of t times x, which is of course just x. And then our x's in the numerator and denominator cancel. So now we have we have the derivative with respect to t of f of t is equal to this. We'll just denote that f prime of t. Okay, so now we have f prime of t. Let's see. We can use partial fraction decomposition on this. And you know what? Normally I don't show this work, but I really want to solve this step by step all the way through. Just to, mostly for myself, just to prove to myself that I can still do this kind of mundane stuff. All right, so let's set up our partial fractions. So we're going to have this, and we want it to be equal to, let's see, some value a over x squared plus 1. And since our powers in both of these fractions are just going to be squared, we don't need to add the plus bx. So we'll just do plus b over t squared x squared plus 1. Okay. Well, what that's going to mean is that a times this quantity plus b times this quantity is going to be equal to 1. All right. So let's see. What does that mean? Well, first of all, that means that we can see clearly that this means that a plus b is going to be equal to 1. That's going to be our constant terms. All right, and what else does that mean? That means that a t squared x squared plus b x squared is going to be equal to 0, because we can say that this is actually 1 plus 0 times x squared, right? Okay, so what does this give us? We can divide both sides by x squared, assuming x is not 0. And we're going to assume it's not. Okay, so we have this. All right, so we have a plus b is equal to 1. And we have a times t squared is equal to b. So let's bring this b over here like this, negative b. And then we'll put over t squared. And therefore, you know what? Let's keep this over here. and we'll just say that b is equal to negative at squared. B is equal to negative at squared. All right, well, if b is negative at squared, we can go ahead and replace it in this one. In fact, I'll make a new version down here, and then just put that there. And then we can factor out an a. So we get 1 minus t squared. Therefore, a is equal to 1 over 1 minus t squared. Great. Okay. So if that's true, well, we can replace this a with 1 over 1 minus t squared. And then let's just write b. Let's see. Let's just take this over to the other side, minus this. Okay. And then let's make this 1 just a 1 minus t squared over 1 minus t squared. Oops. Sorry. 1 minus t squared over 1 minus t squared. And then we just have a minus 1. Okay, and then 1 minus 1 is, of course, 0, so we just have a minus t squared over 1 minus, negative t squared over 1 minus t squared. And now let's replace our parts. We have our b and we have our a. So let's go back up to our original equality here, and let's paste our a value, which is 1 over 1 minus t squared. And then our b value, which is negative b, or negative t squared over t squared minus 1. Okay. All right, let's simplify this. We'll bring this negative sign out to make this just minus. And then let's go ahead and factor out 1 over 1 minus t squared outside. Okay. And then we'll just be left with a t squared right here. And now I'm going to delete the rest of this stuff. We don't need it anymore. And let's go ahead and verify this. So for various values of t, we should get, yeah. Let me bring out the graph of this and show that it does match. Yeah, it matches. Okay, good. Good. Okay, so that's legit. I didn't make any mistakes. All right, so now we have this. This is equal to this. And let's go ahead and delete the rest of the stuff. Okay, so let's use this in our f prime of t. All right, so that means f prime of t is going to be equal to, well, let's see, 1 over 1 minus t squared, and then we're going to have two separate integrals. Integral 0 to infinity of, let's see, 1 over x squared plus 1 dx, and then minus integral 0 to infinity of t squared over t squared x squared plus 1 dx. All right. Did I do that correctly? Yeah, I brought that out, and then we just integrate 0 to infinity. Yeah. Okay, so that's correct. I think. I make mistakes, though I am human. If I did make a mistake, I'll go back and fix it. All right, let's go ahead and bring this t squared outside. All right. And then let's just state right off the bat that this is pi over 2. Yeah, we don't need any of that. We don't need to do that. I will perform the actual the integration on this. There's a formula. I should know it. I believe it's pi over 2t. In fact, I'm going to check that. I believe that's pi over 2t. See if I make t2, 3, 4. Yeah. Yes. that is pi over 2t. Okay. So again, I actually will not be performing the integration on that. There's a formula, and we just get pi over 2t. So this is going to give us, let's see, t squared up here. One factor cancels, that cancels, and now we're just left with this. All right, well, what's that? F prime of t is equal to that. Okay, well, we want f of t, though, don't we? We want f of t. That's what we're trying to do. So that's going to be equal to pi over 2 times the antiderivative of 1 over 1 minus t squared dt, and then minus pi over 2 times the integral in fact, let's go back here. Let's factor out a pi over 2 everywhere. Pi over 2. That gives us 1, and this just gives us minus t. Great. And then we can bring this 1 minus t right on top. And this factors into 1 plus t, 1 minus t. So we have 1 plus t, 1 minus t, and then the 1 minus t's cancel. Great. Okay, so that's our actual f prime of t. So now this makes it much easier. F of t is just going to be pi over 2 times the natural log of 1 plus t plus c. All right. Well, we noted before, well, actually, we didn't note it. We didn't note anything. So let's note it now. F at 0 is going to be equal to 0 because our tangent of 0 is 0. So we'll use this. I should have stated that earlier. But f of 0 is equal to 0 implies, which is also equal to this evaluated at 0. So we just have natural log 1, which is 0, making this whole thing go away. So that implies that c is equal to 0, and therefore f of t is equal to this, which means finally that this is true. For t greater than or equal to 0. All right, guys, that's it. I hope you enjoyed that, and we will see you next time.